As the slide said, logarithms are exponents. Just another way of calling them exponents. When we're told that the log is 3, that means that the exponent is 3. Logarithmic functions and exponential functions are also inverses of each other, which means if we switch the x and y, and reverse all the operations, we can translate from logarithmic to exponential. So we can transfer from one kind of function to the other. In other words, if we know the logarithmic, we can find the exponential. If we know the exponential, we can find the logarithmic. Because we started with exponential functions, let's look at the exponential functions first. So with an exponential function, we know the base, which here is called b, and we know the exponent, which here is called x, and we find the answer to the multiplication after we have raised b to the x power. Which here is called y. So if we know the base, we know the exponent we're using, we multiply that base however many times we need to, we get the answer to the multiplication. Okay, for logarithmic functions, the x and the y are going to get switched. In this case, y equals log b of x. B is still the base. X is the answer to the multiplication. We know the base, which is still b, and we know the answer to the multiplication. Which is a long word to spell. And the answer to the multiplication isn't y anymore. The answer to the multiplication is x. We find the exponent that makes this happen. And that missing exponent is the y. So it's going to take a little getting. So the logarithmic functions, we have that y equals log base b of x. We know the base, that's still called b, and we know the answer to the multiplication, which is called x now. X isn't the exponent anymore. X is the answer to the multiplication. And what we're going to find is the exponent that makes this happen. So with the exponential, we knew the base, we knew the exponent, we were looking for the answer to the multiplication. With logarithmic, we know the base, we know the answer after the multiplication. We're trying to find the exponent that made this multiplication come out that way. Today we're going to work just on translating back and forth between the two. We won't try to solve any. So let's start with changing a logarithmic equation into an exponential equation, which would help if I spelled it better. Okay, so suppose we have 4 equals log base 3 of 81. So 4 is the exponent. The log is the exponent. So 4 is the exponent on base 3 to get 81. Because remember, this is the answer to the multiplication now. So the easiest thing to pick off is base 3. Base 3 is at the bottom. So we know we're going to have 3, that's our base. 4 is the exponent, so it's going to be raised to the 4th power. And it's supposed to come out to 81. So 4 equals log base 3 of 81 is the same as 3 to the 4th power, base 3, with an exponent of 4 will come out to 81. About another example. If we have -1 equals log base 5 on 0.2. Okay, so the log is the exponent. The log equals -1. The base is 5. So that means if the base is 5, the exponent is -1, and that must come out to 0.2. Which it does. We could check that 1/5 is the same as 2/10. But this and this say the same thing. Log base 5 0.2 equals -1 is exactly the same as 5 to the -1 equals 2/10. Except one's in exponential form, one's in logarithmic form. So let's try a few more. If we say log base 16 of 4 equals 1/2. And we're asked to rewrite that in exponential form. That's something to an exponent equals whatever. Well, we can tell the base. The base is 16. Whatever the log equals is the exponent. So the log equals 1/2 means the exponent is 1/2. So far we got base 16 raised to the 1/2 power. The answer to that should be 4. Now you remember that the 1/2 power means square root, so this does indeed work. How about we try another one? It says log 100 equals 2. And there's no base. This is a common log. Common log means that the base is 10. It's the common log because our number system, our whole number system, is based on powers of 10. So that's where it gets the name common log. If you look at the log key on your calculator, means base 10. Means what power on 10? So we could think of this as log base 10 on 100 equals 2. And when we translate this into exponential form, we have a base of 10, the log is the exponent, and 10 to the second power, the answer to the multiplication is 100. Which means we have to be careful. If we forget to write the base number, it automatically becomes a base of 10. And they really don't favor us writing this. They would prefer just plain old log. If we mean base 10, they prefer us to shorten it to just plain old log. One more. Of these, this one is the natural log. ln doesn't put the base in here either. It means that the base is e, the natural growth factor. So when you see this, think of it as log base e on 0.368 is approximately equal to -1. But they really don't want you to write log base e. They want you to write ln. So the ln means the base is e, and this natural logarithm equals -1, so this is e to the -1 power, because the logarithm is the exponent. It's approximately equal to 0.368. Finally, let's take an exponential equation and translate it into the logarithmic form. So if we have 7 to the 3rd power equals 343. We're supposed to translate that into the logarithmic form. We know that the base is 7. We know that the log, which equals the exponent, equals 3. So we could write this as 3 is the exponent on base 7 to get 343. 3 is the exponent on base 7 to get 343. That's a little strange. We could also have said log base 7 on 343 equals 3. That the exponent on base 7 to get 343 is 3. Just turns this sentence around backwards. Maybe we try another one. So this is the exponential form. We have a base. The base is 8. The exponent, which is the same as the log, is -1. So we can write -1 is the exponent on base 8 to get 0.125. Or we can reverse the sentence. The exponent we put on base 8 to get 0.125 is -1. Just 2 more. Okay, we know the base is 10. And the exponent which is the same as the log, equals 8. So we can say 8 equals, and this is a common logarithm, base 10. We do not write the base 10. Or we could say that the log on 100 million is 8. The power that we'd put on base 10 to get 100 million is 8. Last one. We have the exponential equation that e to the 5th is approximately, I hope I copied this right. We know the base is e. We know that the exponent, which is going to be the logarithm, is 5. So we could say that 5 is going to be the approximately equal to the exponent, but we're not going to put log base e. Well, we can put log base e. But they're not going to like that. They're going to want that 5 is approximately equal to ln 148.41316. Rather than log base e, they would prefer us to write ln. Or we could say the ln of 148.41316 is approximately equal to 5. So you have a relatively short assignment on a separate paper, and you can check some of your answers on that same paper. And in the next class, we'll try to solve these things.